Hello students, welcome to maths class. So we are dealing with definite integral 7 marks problems, right? So reduction problems. In integrals we did reduction, no? For that we are applying limit here. It is nothing but a continuation of reduction problem of your integration. In integration we did all the reduction problems. For them we are applying the limits now. Okay, so now come to, if in is equal to integral 0 to pi by 2 sine to the power of n x dx, then show that in is equal to this one. Okay, so come on, first you take what is given to you. It is in is equal to integral 0 to pi by 2 sine to the power of n x dx. Okay, so first we have to reduce, then we have to apply the limits. So come on, how we will do it? Integral 0 to pi by 2 sine to the power of nx into dividing and multiplying, isn't it, with sin x, right? Multiply and divide, or divide and multiply, right, with sin x we are doing here. So after that is equal to, this is your in integral 0 to pi by 2. Come on, this is 1. A to the power of m by a to the power of n is a to the power of m minus n. So we will write this as sin to the power of n minus 1 x into sin x into dx. Okay, now it is of the form f of x into g of x form. So integral f of x into g of x dx is equal to, come on, how we will take? It is f of x into integral g of x dx minus a big integral d by dx of f of x integral g of x dx whole dx, right? This is your f of x into g of x form. So you consider this as f of x, this as g of x. Then in is equal to f of x, it is sine to the power of n minus 1 x integral sine x dx, right, g of x form, minus integral of d by dx of sine x. We can write this as sine x to the power of n minus 1. Sine n minus 1 x or sine x to the power of n minus 1, both are same. Integral sine x dx whole dx. Okay, so is equal to sine to the power of n minus 1 x into integral sin x is minus cos x minus, come on, d by dx of x to the power of n form, any value to the power of, right, x is having any value as the power, then d by dx of x to the power of n is n into x to the power of n minus 1 into d by dx of x. So in n place we are having n minus 1 sin x to the power of x, right, sin x to the power of n minus 1 minus 1. So it is n minus 2 into d by dx of sin x. Integral sin x is minus cos x into dx. Okay, so is equal to minus sin x to the power of n minus 1 into cos x. Once integral over, we have to take the limits on right side. So it is 0 to pi by 2, isn't it? Here integral is 0 to pi by 2. So 0 to pi by 2. Here also 0 to pi by 2. 0 to pi by 2 will be there. Okay, so then here minus of minus plus, it is a constant, you write outside n minus 1 integral 0 to pi by 2 sin x to the power of n minus 2 into d by dx of sin x is cos x into cos x dx. Okay, so come on. Now here in this, first we have to substitute in x place upper limit pi by 2 and in x place we have to substitute lower limit 0. Okay, so it is first upper limit you take minus sin x place pi by 2, right, to the power of n minus 2. Next into cos of x place pi by 2 we have to take. Okay, so this is upper limit. Next minus lower limit we have to take. How? Minus sin of in x place 0 to the power of n minus 2 into cos of x place we have to take 0. So this is upper limit minus lower limit over. Next you come to this one. In this expression in x place, first I substituted the upper limit minus in x place I substituted the lower limit. Now come to the next one. Okay, so it is plus n minus 1 is constant. It comes outside of the integral 0 to pi by 2, right, and sin of n minus 2x into cos x cos square x into dx. For each integral into dx will be there. Okay, so is equal to now minus of sin 90 is 1, right, so 1 to the power of n minus 2 into cos 90 is 0, right, and minus of sin 0 is 0, so 0 to the power of n minus 2 and cos 0 is 1. So we have taken the values, upper limit values, lower limit values. There plus n minus 1 into integral 0 to pi by 2 sin of n minus 2x into cos square x dx. Cos square x dx, from identity we can write this as 1 minus sin square x dx. Okay, so is equal to, observe here, minus 1 to the power of n minus 2 into 0, 0 into anything is 0, minus here also 0 to the power of anything is 0, 0 into 1 is 0. Okay, so plus n minus 1 integral 0 to pi by 2. Come on, open the brackets now. So first one with this, next sin square x with this one. So come on, how we can take? It is sin to the power of n minus 2x minus, come on, sin to the power of n minus 2x into sin square x dx. Okay, so it is whenever inside the integral, if plus minus is there, we have to take the separate integrals, right? So this is 0 plus n minus 1. Take the integral separately. Integral 0 to pi by 2 sin of n minus 2x minus, come on, take n minus 1 outside, integral 0 to pi by 2, a to the power of m into a to the power of n. In a product, if bases are same, power should be added, isn't it? So sin to the power of n minus 2 plus 2 we have to take, isn't it? Sin to the power of n minus 2 plus 2x dx. It is of the form, which form? A to the power of m into a to the power of n is equal to a to the power of m plus n. Okay, so is equal to, here plus 2 minus 2 cancel. Which value we are finding? We are finding in. So in is equal to n minus 1. We can write this as in minus 2. Okay, minus n minus 1 into in. This is in. Okay, so this side we are having in, bring that in this side. So in plus n minus 1 into in is equal to n minus 1 in minus 2. Okay, so we can take in common. So take in common. So 1 plus n minus 1 is equal to n minus 1 in minus 2. So plus 1 minus 1 cancel. So n is equal to n minus 1 in minus 2. We want in value. So here n is multiplying. If you send that side, it will divides. So in is equal to n minus 1 by in minus 2. Okay, so this is the answer. Show that see in is equal to n minus 1 by in minus 2 is the answer. So how we have to prove? So first you consider it is given in the question only in is equal to. So you take in is equal to integral 0 to pi by 2 sine to the power of nx dx. We are considering that value as in. It is given in the question itself, right? Then multiply and divide with sin x, right? So sin x means sin x to the power of 1 also we can write. Any value can be written as that value to the power of 1. Now there is one formula. What is that? A to the power of m by a to the power of n is equal to a to the power of m minus n. So same thing here, sin to the power of nx by sin x to the power of 1 is nothing but sin to the power of n minus 1x. A to the power of m by a to the power of n formula we applied there into sin x. This sin x comes as it is. Now it is of the form, which form? Integral 0 to pi by 2, isn't it? F of x into g of x form. So you take the formula integral f of x into g of x dx is equal to f of x integral g of x dx minus integral of d by dx of f of x into integral g of x dx whole dx. Suppose if we take for this the limits 0 to pi by 2, it comes like that. Therefore your formula is in is equal to, we have taken this as in is equal to integral 0 to pi by 2 sin to the power of n minus x into sin x dx. So same thing we are getting here. Okay, so after the completion of integral sin x is minus cos x, our roots will come in the right side. We have to write the limit 0 to pi by 2. Okay, and here also d by dx of sin x is minus cos x. If you observe, here minus is there, here minus is there, minus of minus plus, and this is n minus 1. It is a constant, write n minus 1 outside. So integral 0 to pi by 2 sin to the power of n minus 2x, and d by dx of sin x is cos x. And already cos x is there. Cos x into cos x is cos square x. Okay, and if you observe, after writing the limits on the right side in x place, first we have to substitute the upper limit. So substitute wherever x is there pi by 2 in the equation. Next minus in the same equation wherever x is there, we have to substitute lower limit as 0. Okay, so it is sin 90 is 1, cos 90 is 0. Next sin 0 is 0, cos 0 is 1. Okay, so plus n minus 1 integral 0 to pi by 2 cos square x from the identity cos square x can be written as 1 minus sin square x. So come on, after that you open the brackets, this into 1, this into this, and inside the integral whenever plus minus sign is there, we have to take the separate integrals. So I have taken integral for this term separately, for this term separately. And if you observe this one, this is of the form a to the power of m into a to the power of n. That means in a product, if bases are same, power should be added. So powers are added there. Plus 2 minus 2 cancels. So we got n, and this is nothing but 0 to pi by 2 sin to the power of nx dx. In the beginning they have given that as in, so in its place we can take in, and instead of n here 0 to pi by 2 sin to the power of n minus 2, in in sin to the power of n is there, instead of n minus 2 is there, means in minus 2. So in its place we can write in minus 2, that is in. So here also in is there, here also in is there. Try to write in terms together. So in plus n minus 1, in is equal to n minus 1, in minus 2. So these are